Okay, so we have example 4 here. This says, consider the table below. The data comes from the Titanic. So we have columns that divide up the people on the Titanic by men, women, boys, and girls. And we have rows that divide them up whether or not they survived the Titanic accident. So the thing you have to keep in mind here is that when we're finding probabilities, the first thing you want to notice is if we're looking for the probability of something or something, or the probability of something and something. So from this class, we learned that the probability of A or B occurring is equal to the probability of A plus the probability of B minus the probability of A and B. Okay. So before we actually do this, I'll look at a different example. Let me just see if this makes it better. Is that okay? So let's say I have a series of marbles. I have, let's do it like this. I will draw a circle, and this is going to be red. Let me do that again. Okay. So I have 9 red marbles. And then let's do this with blue marbles. Let's say I have blue marbles. And I have 6 blue marbles. So the thing to keep in mind here is that these marbles are going to be numbered. This will be numbered 1, 2, 3, 4, 5, 6, 7, 8. So there's the 9 red, and I have 1, 2, 3, 4, 5, 6 blue. Now, what if I said I want to pick a random number from this bag that all these marbles are in? So you can't see them; they're in a bag, and I want to know the probability. If I pick one marble out at random, what's the probability that it is even or blue? So what's the chances that it's even or blue? Well, to figure that out, I would first take all of the even marbles. So even marbles, this is 1 here, 2, 3, 4. Those are all even. Oh, I messed that star up, whatever. This is even, this 2, this 4, and this 6. So we have 1, 2, 3, 4, 5, 6, 7 even marbles. 7 of them are even out of a total of 15. Okay, then I'm going to add the blue marbles. So if I do this, let's do this in orange. The blue, I have 1, 2, 3, 4, 5, 6. I have 6 blue marbles. So that's going to be 6 out of 15. But that's too many. That's going to be 13 out of 15, which means there's only 2 that aren't blue or even. But we can see here there's more than 2 that aren't blue or even. The problem is that I've counted 3 marbles twice. I counted these 3 twice, which are the blue even marbles. Those are the ones that are blue and even. So I have to subtract those. So I'm going to subtract 3 out of 15. Those are the 3 that are blue and even. And I get 7 plus 6 minus 3. That's 10 out of 15. And if you put that in the calculator, you get 2/3. But 10 out of 15, that means there's 5 marbles that aren't blue or even. They must be red and odd. Well, there's 1. Let's do this in a different color. There's 1, 2, 3, 4, 5. There's the 5 that are not blue or even. So we're going to use the same logic on this problem here. So this says find the probability of randomly selecting a man or a boy. So that's going to be the probability of a man. All men. How many men are there that I can pick from? Well, the total number of men is this 1692. So this is going to be 1692 over the total number of people, plus the probability of a boy. Any boy living or survived or not. So that's this entire column. Well, that's 64 boys over 2223. Minus the probability of selecting a man and a boy. Well, since there are no people on the Titanic that are both men and boys, these are completely separate groups. This is 0. There's nothing to subtract here. These are mutually exclusive groups. We call them mutually exclusive. So it's a matter of just adding these two together. So I get 1756, I think, out of 2223. Let's see. 1692 plus 64. 1756 divided by 2223. Let's see if that will reduce. It might. Nope, it doesn't. So that's our answer. Now here we're going to have overlap. So this is the probability of selecting a man, which is still 1692 over 2223, plus finding the probability of someone who survived. Anyone who survived. That's all survivors. That's the total number of survivors. But just like with the marble problem, now I've counted some people twice. I counted all the men. I counted all the survivors, which means I counted this group twice. The men who survived, men and survivors. So I have to subtract 332 out of 2223. And that I can put in the calculator. Again, this is going to be 1692 plus 706 minus 332. So I get 2066 divided by 2223. Let's see if that reduces. Don't think it does. Nope. There's our answer. 2066 over 2223. And that's how you use the OR probability formula.